Hello everyone. In this session we shall discuss about the two very important and very basic concepts in mathematics. One is multiples, the other one is LCM, least common multiple. So what is this multiple? Where from this concept originates? So we all know the multiplication table, okay, for every number. For 2 it is 2 ones are 2, 2 twos are 4, 2 threes are 6, and it goes on like that. For number 5, 5 ones are 5, 5 twos are 10, 5 threes are 15, and it goes on like that. So in multiplication table, the numbers at the rightmost column, okay. For 5 it is 5, 10, 15, 20, 25. For 3 it is 3, 6, 9, 12, 15, like that. So the numbers in the rightmost column in the multiplication table, the final answers, they are the multiples of that number. So the multiples of 2 are 2, 4, 6, 8, 10, etc. The multiples of 3 are 3, 6, 9, 12, etc. And the multiples of 10, you can find them in the multiplication table. For 10, they are 10, 20, 30, 40, etc. And these are the multiples for 17 and 19, okay. And the multiples of a number, they are the number multiplied by 1, 2, 3, 4, 5, etc. okay. You can find those multiples in the multiplication table. If you want to find the multiples of a number n, you can find those multiples in the multiplication table for n. What are the multiples for n? N, 2n, 3n, 4n, 5n, etc. So now we have to find the least common multiple of 4, 6 and 10. 4 will have so many multiples. 6 and 10 will also have so many multiples. Now you have to find the common multiples, okay. Definitely there will be some common multiples. Amongst the common multiples, you have to find the least common multiple, the first one, okay. So now we will see the straightforward method, the simplest method. Of course it will become time consuming, okay. So what are the multiples for 4? I have listed, I have given a very big list here. The multiples of 4, 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, up to 4 15s are 60, 4 16s are 64, 4 18s are 72, and these are the multiples for 6, and these are the multiples of 10, and definitely we can find some common multiples here. For example, 60 appears in all the three lists, and 60 also happens to be the least common multiple. So you have to carefully observe the three lists and list out the common multiples. Once you list out the common multiples, the first one will obviously be the least common multiple, okay. But this process is somewhat time consuming, even though it is straightforward and simple. So this is another technique. Find the LCM for 8 and 5. Here you first take the higher number. What is a higher number? Higher number is 8. You generate 5 multiples for 8. 5 is the other number given in the problem, okay. So you take the higher number 8, you generate 5 multiples, okay. 8, 16, 24, 32 and 40. Now generate the multiples of the lower number until the first number in that list matches the number in the previous list. This is the first list, the 5 multiples of 8. Now you take 5, you start generating the multiples 5, 10. While generating each number, check if that number is in the previous list. If that number is in the previous list, then that is the least common multiple. So obviously when you reach 40, then you have the common multiple. This 40 is present in the previous list also. So 40 is the LCM. Even this method becomes complicated when we have larger numbers in the problem and also more numbers. Here only two numbers, and those two numbers are very small numbers, they are single digit numbers. For example, you have triple digit or 4-digit numbers and 5 numbers are given to you and you are asked to find the least common multiple, then this procedure becomes immensely complicated. So you cannot use this. Now we will see a very simple method which can be used, that is by using prime factorization. Okay, you have to find the prime factors of each given number. Now what is the problem? The problem is find the LCM for 12, 15, 20 and 24. These are all 2-digit numbers, and how many numbers are given? 4 numbers are given. Okay, so you just find the prime factor for each number. Okay, so we have two techniques. One is the factorization tree, the other one is the repetitive division method. So here I am using the repeated division method. So for 12, how to perform this method? You select the first prime number, that is 2, and 2 6 are 12, 0 is the remainder, 2 3 are 6. Now 2 into 2 into 3, you got all the prime numbers and they are the prime factors for 12. So 12 can be represented as 2 into 2 into 3. This dot represents multiplication operation. So for 24, again you perform the same method. You start with 2. 2 is the initial divisor, 24 is the dividend here, and 12 is the quotient and 0 is the remainder. So 2 12s are 24, 2 6 are 12, 2 3s are 6. Okay, and what is the prime factorization for 24? It is 2 into 2 into 2 into 3. For 20 it is 2 into 2 into 5, because 2 10s are 20, 2 5s are 10. So 2 into 2 into 5 will be the prime factorization for 20, and the prime factorization for 15 is 3 into 5. Now you have got the list of prime factors, the lists of prime factors for all these numbers. Now you have to carefully observe those lists. You have to select every prime factor, not the common prime factors in GCD. In LCM, you have to select every prime factor. You cannot leave anything behind. So 2 is appearing here, 3 is appearing here, 5 is appearing here. Only 3 prime factors are appearing in all the 4 lists. So you select all 2, 3, 5. Now there is another question. 2 appears twice, 2 appears 2 times here, 2 appears 3 times here, and 2 appears 2 times here. So which repetition you have to take? Whether you have to take 2 times repetition or you have to take 3 2's. Here you have to take 3 2's. That is another difference from the GCD method. In GCD you have to take the smaller repetition. In LCM you have to take the greater repetition. Okay, so you will have to take 2 into 2 into 2 into 3 into 5. And what is the answer? What is 2 into 2 into 2? It is 8. 8 into 3, it is 24, and 24 into 5, it is 120. That's what I have done here on the right side. And this is the end of this wonderful session. We shall continue later. Bye bye.